Okay. Hello. Hola. Hi. My name is Mike Amundsen, and this is Handy Tools for Designing Great APIs. Thank you very much for coming at 3 o'clock, the second to last talk on the last day. I really appreciate that you came in instead of just enjoying the city. So hopefully we'll have some fun in this next hour. As I said, my name is Mike Amundsen. I live in Kentucky in the United States, but I travel a lot. The best way to find me is actually through my handle. So this will get you to my LinkedIn, my Twitter, and my GitHub. Last year I traveled about 40 weeks of the year. So that's about 3 weeks a month, and that's a lot. But the great part about that is I get to meet really smart people doing amazing things in amazing places. So that's really what I'm sharing with you today, things that I've learned from other companies who are doing this work in APIs, as well as with my colleagues. I worked in a group called API Academy for 6.5 years. We've since broken up. The band broke up, so to speak, and we're doing different things now, but a lot of the things I learned from my colleagues there as well. If you want to see more about what I teach and what I talk about in my classes, you can visit the training site there. These will be in the slides. My Academy colleagues and I just completed a book in December called Continuous API Management. So it goes a little bit past the idea of just having an API. It's what happens when I have lots of them. How do I manage them? How do I control them? How do I make sure they all work together in some consistent way? So some of the things I'll be talking about, especially in some of the design patterns and the design thinking element, comes from this book as well. And there's a lot of material on APIs as products and team building and lots of other things there. You can find that at that site as well. So there are a handful of things that I wanted to talk about today. Each one of them is sort of their own topic, their own construction, and they have their own kinds of tools. But I wanted to talk about this notion as APIs as a product. We are encountering lots of organizations, large and small, that are thinking of their APIs in a very product-oriented way. Sometimes that's because they're consumed products. You think of Stripe or Twilio or even Netflix or some of these other organizations. They only exist because they have an internet API of some kind that clients can use and that servers can use. At the same time, when you start thinking about products, even if they're industrial manufactured products, even if it's the way you design your manufacture process, you really have to think about design. You have to think about it in a different way. Design becomes a way of thinking about what you do rather than just a simple act of designing an interface or something like that. So we'll talk a little bit about design thinking in general and patterns that I'm seeing in companies. And then we'll get to an API design method. This is a method that we've kind of combined lots of organizations' patterns into one seemingly useful one that other people use. And there are lots of tools that can be associated with this. And I'll be talking about this mostly from the standpoint of programmers or developers or team leads, not necessarily just designers themselves. We're seeing organizations bring designers into the company, bring product designers, market designers, industrial designers into the company where they're programmers, but often they're just visitors. So those of us who write and develop, as well as those who are responsible for creating designs, need to learn some of these as well. So we'll tick through a handful of tools for that. And what we're finding is eventually this kind of pattern creates a virtuous cycle. If you start thinking about your APIs and your services as products, you start working through the design thought process, you start using some of these tools, and then that makes it easier to think about your APIs as products and design them better and so on and so forth. So it's sometimes referred to as a virtuous cycle or sometimes the flywheel effect. There's even a phrase called bootstrapping, where once I get good at something, then I can sort of raise the bar and I can get better at it the next time. So that's really kind of what a lot of this turns into. Okay. So to sort of start out on that idea, let's talk about this notion of APIs as a product. It's used a lot in the areas where I talk about. There's also a thing called API first mentality, which is I'm going to design the API, the interface, and then we're going to build the things around it. And I'm going to think about the API as if it's a consumable item that others are consuming. And I love the fact that if you look up in English dictionaries, There are a couple of definitions for a product, and both of those really have bearing on the kinds of things we're seeing going on in organizations. The first one of these is simply something that's manufactured or refined for sale, something that is going to be consumed by others. So I mentioned companies like Twilio and Stripe, and there's a handful of API-type organizations. Their only product is their interface. Salesforce is probably the best example of this. Their only product is their interface, and they've monetized that interface completely. So that's one aspect of it, designing something that other consumers want to use. Not as something that's annoying, not something that's complicated, not something that's easy to make a mistake on, but something that's easy to use. Salesforce has been in business for 10 years, and they've never broken a customer's interface. They've never made a breaking change, yet they've completely evolved their interface over the years. So how do they do that? They do that because they think of the customer first. How do I make sure they don't get a bad product because they're paying us money? But the other definition I really like is the result of an action or process. And often that's kind of this internal design strategy. Our process for designing things, our process for creating, this is our product, this is our work product, this is what we do every day. And every team, whether your APIs are consumed by the outside or they're just consumed by another team inside the organization, seeing it this way as our product and our process and our output gives you a chance to start to model the process and start to use some standardized kind of industrial design tools to make sure that your process meets specification. Because what happens is when you get into a manufacturing where your part becomes assembled with other parts, you need to make sure that you meet the specification for size and shape and color and weight and stress, all those details to make sure that your product is matching the specification so that it can be combined into something else. And that's a real challenge in software APIs, is thinking about your API as just a part of the overall solution. Often we think of the API as the solution. We're going to build a server that does the solution using an API. More and more frequently, companies are combining APIs for one solution. A little bit of your API, a little bit of this other team's API, a little bit of SAP, a little bit of Salesforce. Now we have one solution. So getting those to work together is important too. So when we were doing some research, we talked to lots of different companies about why they have what they call an API program. What is their initiative? What is their motivating value? What is their business strategy here? And we saw a couple of things emerge. As I'd mentioned, there's a group of people who are saying their API is their external consumable product. So they're designing and they're adopting practices that make their product saleable, marketable, monetizable, and that's the key, whether it's Google Maps or Salesforce or SAP or Stripe or Twilio or any of these other companies. So that's one category. But there's another category that's rather large that we end up talking to. And these are organizations that say they're building their API program because they want a toolkit, a platform, a series of things that they could kind of puzzle together to build a solution. And what they're really trying to do is not generate revenue, but reduce cost, reduce the cost of change over time. So they focus a lot on sort of an industrial design approach to designing their APIs. How can I make sure that they meet specifications? How can I make sure that I still allow enough innovation and change over time that things can get better without breaking the production line, without breaking systems? So that toolkit approach is pretty important. We also have a group of customers that tell us they're adopting an API program because they're trying to re-engineer their existing organization. They will say words like technical debt, they'll say like modernization, or they'll say transformation, and they're using an API program to change the way they do business, to go digital or something like that. Typically, these are large enterprises that are trying to catch up or trying to close a gap that they have. They also are very much interested in reducing cost of production and change. They also want to increase the speed of being able to solve a problem because they're in a competitive space. What we've learned in these three cases, the product orientation, the industrial toolkit orientation, and this orientation on transformation, this one is the most dangerous. This one is the most costly. This one is the most likely to fail. So transforming an existing thing into something else is an incredibly dangerous operation, and it takes a lot of patience and a lot of time. I'll give an example. Netflix designed a process where they moved from on-premise servers to cloud servers. That was a big part of their overall tactic, their long-term strategy, their business strategy. They wanted to move to the cloud. They wanted to get rid of some things, and they wanted to change some things, and then put them up in the cloud. So that took them a little bit of time. As a matter of fact, when they wrote a blog post in their public engineering blog in 2016, they said that they were very happy to say that they finally shut off their last on-premise streaming server, and that what only took, to complete this whole process, only took 8 years. Okay, so that's Netflix, right? That's the people we think are like super cool and all digital and everything, and they don't have the weight of what it takes for, you know, a large bank or an enterprise. They took 8 years to convert their on-premise VMs into EC2 instances at Amazon and get the last server booked onto the cloud by 2016. Of course, in those 8 years, that infrastructure team had chosen EC2 instances as their strategy, as their technology. Well, by 2016, there was a new technology for hosting in the cloud, and that was containers. So what did they also announce in that same blog post? That now that we have everything moved to EC2, we're going to start looking at a program to start working on whether or not we should go into containers. So the process doesn't end, right? It keeps going all the time. And this was really a well thought out, well designed process, and it just takes time. So commitment to these things takes a lot of energy and a lot of longitude, a lot of time, work over time. So just to back up a little bit, API programming interface, application programming interface. The most important word in there is interface. It's an interface. We design user interfaces with great care and lots of testing in most of our products. We want to make sure that it's got the right fields and the right inputs and the right look and feel, and it's hard to click on the delete button and so on and so forth, right? We need that same interface design attention when we're doing APIs, because we know how user interfaces can frustrate us or make us angry or make us look bad or make it easy to delete or break something. We get frustrated by those kinds of apps. Well, the same thing is true for your APIs. APIs need to be designed in a way that actually help users figure out how to use the interface, how to use this interface to solve a problem. If we just simply gave users a bunch of inputs with names and a button that said submit, that would be considered a bad user interface. And yet that's almost always what we see customers do with their APIs. They give them just a bunch of data fields and they say, here, go ahead. So when you don't have a well-designed user interface that's informative, that has a lot of metadata about what's going on the screen, for users it's color and size and shape and placement. When you don't have those kinds of features in an API or in any device, instead you have a user manual. Right? So a user manual. I don't need a user manual for this, luckily for me, but I have a home console remote for my video system that has 40 knobs on it, and I need a user manual for that. Most of the times, APIs don't operate like this. They operate like those 40 different things, and we have big user manuals we call documentation. And you really can't work well without it. And it's hard to write documentation to stay up with the changes in the API. So improving the design of the API can actually improve the effectiveness of developers, reduce the chances they're making errors and mistakes, reduce the chances of them writing code that actually overloads servers. Good design can really change a lot of that. Because good design of APIs makes interaction easy. We want to make it easy for you to interact with your target audience. We want to make it easy for you to reach the data you need. So a big part of this design thinking is thinking about solving this problem. How do I make interaction easy? How do I make this easy for everyone? How do I increase the safety, reduce the cost, and reduce the risk? And that gets to this notion about thinking about design, a meme that's about 10 or 15 years old now called design thinking. So design thinking is this notion of putting on sort of like a thinking hat and having this sort of habit. So we'll talk about where it comes from in a minute. But again, I like the definition, the English definition, a plan or drawing produced to show the look and function of some object that is made. So it's a plan or a drawing or a process. So design is actually writing out the details that tell us what this is eventually going to be. Physical architects go through the very long design process, and they write things out, they sketch things out, they build prototypes, they build small models, and then they put together a thing called a blueprint. And they hand it to people that they will never meet. They hand it to people they probably will never talk to and trust them that they will build it according to the blueprint and that the blueprint has enough in it to allow them to build the building. And that's pretty hard for us as programmers. We don't have that kind of culture or that kind of history of spending all that time on that design phase and then handing over a completed blueprint and then doing something else. Often we change things as we go. So the idea of design thinking actually was made popular by this gentleman, Tim Brown, of IDEO, which is a product marketing and design company. He wasn't the first to think of it. It's been going on for a long time, but this definition or this idea of design thinking is pretty common. And I love that he's got some key elements in the way he talks about this. Matching people's needs, technologically feasible, viable strategy, customer value, and market opportunity. There's a lot there. You could do a whole talk just on that. But very often, that's the stuff that we need to do when we do API design. Who's our audience? Whose needs are we matching? Are we matching our needs, or are we matching the needs of the API consumer? Often when we design APIs, we end up designing an interface for the database. There, go, have fun, I'm done. Well, we're not solving anyone's problem except our own. What we don't want to do is we don't want to have to write custom code every time somebody wants to get at the database. So we design that API. Well, that's a good start, but it's not enough. What happens to somebody in marketing? What happens to somebody in the HR department or the finance department or just some other team in the mobile department? Now they have to know everything about the database, everything about the schema, how to do databases, just to see if they can design their own solution for their own problem. Whereas it would be a much better strategy for them, a much better tactic for them, if they could consume an API which solves their problem. Now, inside the company, it's usually not a big deal. But when your API consumers are partners, it becomes a more important element. Solving the partner's problem rather than your problem is how you get loyalty. So understanding their needs is important. At the same time, technologically feasible, just make sure that we're not trying to do something with hardware or software that isn't possible. Understanding the cost of the network, understanding what transaction time is, understanding I can't do two-phase commit on the web. There's a whole series of things that we have to understand that whether or not it's feasible. And a viable strategy, there's a great quote from one of the people who now works at Red Hat, and he said, you don't want to ask what is the business model for my API. What you want to ask is, what APIs do I need for my business model? In other words, APIs are a servant of the business. They're there to solve the business's problem, to help the business reach its goals, not to be something standalone by itself. So creating an API just because we like it, using GraphQL because it's cool, using Node because it's new, whatever that is, those aren't good business viable strategies for APIs. And in fact, several companies that we've talked to have spent a lot of time and money chasing a new idea without having a great strategy. So that's part of your design as well, and that's where the value to the customer is and the opportunity comes from as well. So this idea of thinking about design is becoming so popular for a lot of reasons. Tim Brown is one of them. This is another one, Stanford's D School or Design School. So startup organizations and lots of other software developers actually go through a program at Stanford in California called the D School program, where they learn about design and they learn about what it takes to think about design in these terms about customers and solving problems in businesses. And D School offers courses online. Several of our customers are actually hiring design trainers to come in and talk to their developers. At least one large consumer bank in the United States actually has designers on staff, and they teach a regular course to their developers on design thinking, how to go through the process of design thinking. There have been lots of other offshoots from design thinking. Has anyone heard of event storming? Event storming, right? We use this in DDD and lots of other places. That's really come out of the same space of building ideas and collaborating with people to get things all put together. You can even see in some of these photos, I think there's some sticky notes around. They use a lot of the same kind of things at the D School. You can buy books on design thinking. You can do courses online for design thinking. You can go to even your local university often. We see more and more of this going on. And one of the key principles that this design thinking training talks about are the 3 elements of every design. And it turns out we design every day. If we're writing code, if we're writing an interface, we're designing all the time. One of sort of the founders of the notion of interactive design is Bill Moggridge, and he has this design. Yeah? Is that okay? Okay. All right. So as I was saying, we're always designing, even if our default design is to not do much, right? Just to accept whatever was given. And the 3 elements that we always have to deal with in every design situation are these 3 things: functionality, usability, and experience. Does it work? Is it easy to use? Do I have fun doing it? Those are the 3 levels of product design. Those are 3 levels of any kind of design you'll work in. So to kind of just give an example of this, I'm going to use one of my favorite things, toast. And we're going to talk about designing the experience of making toast. All right? So here's one way to make toast, right? This is functional. This works. It's fire. I start a little fire in my kitchen. I put some bread over it. I get some toast. Maybe it's dangerous. Maybe it's a little complicated. Maybe you can hurt yourself doing it, but it works. And often we find customers stop at this level of design for their interfaces and their software, right? They're literally not thinking about the dangers they're causing. They're not thinking about how complex it is to do this, whether or not it's appropriate to do this in this place, and how easy it is for someone to make a mistake. They're literally setting a fire inside their organization. So it's a start, but now you have to tell people you have to be really careful, and you put on a suit and you do these things and you have a checklist to make sure you don't make a mistake. And very often that's the way we design our software, or we design things like deployment, right? Deployment is often setting a fire too, because it's so easy to make a mistake somewhere. So we need to get beyond this notion of functionality into something else, and that's where we get to this is a more reasonable way to make toast, right? It's not fancy, it's not complicated. You plug it in, it's got a little plunger thing and a knob that tells me how much toast I'm making here, and I put the bread in and that's it. It's not amazingly fun, but it is usable. And it's hard for me to mess this up. I could burn a couple pieces of toast, but that's about it. I'm not going to burn anything else with it. It makes sure that it contains any damage I have to the stuff that I'm adding to it. And it's hard for me to even break this device. Right? So that's a really good strategy. A lot of companies we talk to, this is where they're aiming. They're aiming for this usability level. They want their APIs to be usable, predictable. They want the knobs and all these other details to look similar wherever I go in the house. If I have 5 toasters in the house, they should all pretty much operate the same, so that I don't need a manual every time I want to use another toaster. But especially if you're looking for APIs for third parties or other organizations to use, people like Salesforce and these other organizations, they need to go to the next level. They need to create a really great experience. Here, I'm not just making toast. I'm making a statement. This is a fancy machine. I've paid good money for this. In fact, I've paid so much money for this, when you come to my house, I'm going to bore you by dragging you over and making toasts so you could see how great this really is. I love this thing. Hopefully, I will actually get over the fact that I spent too much money on it at some point, but I'm not sure. This is where we're starting to deal with experience. I can see what's going on. You know this is fancy because it even has fancy bread, right? It's not regular bread, it's fancy bread. And I've got special custom buttons for making bagels and muffins and whatever the case may be. Not a lot of organizations go to this level unless you're really aiming for an audience. Now your design needs to go beyond functionality and usability. It actually needs to go toward creating a great experience for someone. And there are lots of ways to do that. It doesn't have to be a kind of an exaggerated element, but just making sure people feel good about using the tool. They will tell their friends about the tool. They will introduce that tool into their organization. It doesn't feel like a threat to other things. There's a lot of experience elements to be involved with. So this notion of functionality, usability, and experience are the things that we use when we're about to execute on real design, when we're ready to do some real work. And that leads us to the bulk of what we want to talk about, and that is developing a method for designing APIs. So what do we need to do, and how do we go about doing that? And again, I like looking at these dictionary definitions because they give us some hints, they give us some ideas. So accomplishing or approaching something, a systematically established one, a particular set of procedures. And that's really what makes a good API design program, is not that it makes everybody do things the same way, but it makes everybody go through the same process so that they touch on the same elements. They cover all the things. In the case of functionality and usability, there's some kinds of measures. In the case of how you go about designing and documenting so that you have enough metadata, enough assets, enough collateral to turn over to developers, you can standardize that process. You don't have to standardize what format they use, whether it's JSON or XML, or what the URLs look like, or any of that stuff. You don't have to formalize that. But if you formalize the way you work through this process, then you get a lot of benefit. So this is a sort of a meta set. This is pretty much what I end up doing when I'm working on design, but it's sort of a set derived from lots of organizations that we've seen. Coming up with some kind of documenting of the workflow of the API, or how people will use it in some way. Often these look like maps, or they look like just little drawings or line charts. They're really ways to document what people tell you. Well, I go and do this, or I go and do that, or I need something to do X. A lot of times these are connected to user stories. Users tell us about what they want to do and how they want to do it, and then we design these workflow elements. I'll show a really simple example of them in a little bit. And then literally creating a standardized diagram. So that diagram is something that developers can look at, stakeholders can look at, everyone can look at and make a sense of. And we'll talk about the diagram process that I'm seeing used most frequently, and it's even now standardized by the IETF, the people who make all the RFC standards on the internet, and that's sequence diagrams. We've seen lots of things, actor diagrams and class diagrams and finite state machine diagrams and all these other things, but the most common one is sequence diagrams. And there's some great tools that you can use to create sequence diagrams that make it easy to build them and share them. And another big part of designing an API is managing what we call the vocabulary, or the dictionary of terms. Everyone who works in an API program needs to be using the same terms in that interface, so they understand what words like given name or family name mean. So they understand what a customer means. They understand what actions mean. So you actually have to design this part of the system as well. And the good news is most organizations have something like this in place already, whether it's their schemas, their object models, their data models, and some regulated businesses like health and insurance and banking have published standardized shared committee models on terms like this in objects and titles and properties and so on and so forth. So establishing those as a part of your design process is really important. And then a really important element comes out of this, and that's what we call writing an API profile. An API profile is a description in a machine-readable form of all the properties and actions, all the arguments and return values. So it's like the blueprint element, but it doesn't have anything to do with a protocol or a format. So it doesn't say you're going to use HTTP. It doesn't say you're going to use WebSockets. It doesn't say you're going to use HTML or collection JSON or Uber. It doesn't say any of those things. Those things are implementation details. That's building materials that will be decided on site when they get the blueprints. But this profile is a sort of technology agnostic, machine readable description that other people can use. We've seen variations on how this is implemented. There are a few formalized document formats or languages for this that we'll talk about. I've even seen people just simply have their own internal Confluence document or wiki page or something that's done in a really standardized kind of way. But the idea is to document all the metadata, all the properties, and all the actions in a way that developers will be able to understand. And then finally, you can develop an as-designed API reference. API reference documentation often looks like, has some implementation details in it. It'll have things like this is an HTTP post, or this is a put, or this is a get, or this is a query string. So generating one of those early on is very helpful to developers. Most organizations start with that API reference. However, that API reference is not really good documentation for a lot of reasons. The as-built will be very different than as-designed. In other words, in reality, there will be certain things that don't match up. Plus, these generated API references are missing a lot of important documentation elements that we'll talk about towards the end here that somebody else is going to have to do. And most organizations who do a lot of this try to balance some professional specification writing with their own developers to kind of make the circle complete. Now, the other nice thing about each one of these, designing the workflow, doing the diagram, the vocabulary, the profile, the reference, they're all iterative. So you can go over and over. You can go back and back and back again. And with some of the tools that we're looking at, we'll see here, you can actually chain tools together to start to, once you get from this workflow to a diagram stage, you can actually start putting build tools together that even if somebody goes back and makes a change somewhere, it can ripple through the rest of the system without causing breakage. So let's talk about each one of these a little bit and talk about the kinds of tools that we're seeing. So producing a workflow sketch, as I mentioned, usually comes from a user story or an interview, or somebody's made some request, we need a new feature or something like that. So you need to sketch out generally what people are talking about. This is a really simple idea of maybe somebody says we need a weather API. This is actually based on some US weather data information. So basically, we're going to design something that is a sketch. It just gives you, if you look at it, you have an idea of what might be going on. We start from someplace, we make a request, and we get some data. And actually, we have several different kinds of requests we want to support. Now, this is a very simple item. I don't have a lot of read activity in this diagram. But it's really written in a very simplistic form that most anybody should be able to figure out. What's interesting in this is it has this notion of starting from someplace. It doesn't just say, I want to do this and this and this and this. It says, I want to start from here and then go do this. I want to start from here and then go do that. And that's really an important element of workflow. One of the challenges in APIs is we often design the actions, but we don't design the way they're traversed. We don't design how you get from A to B. And then that gets left up to developers to do. And especially when we're creating APIs, what happens is you don't get a sense of motion or movement or completing a task, and when you want to combine them, they become really difficult to do. So doing it early on is really important. Typically, we would just see people writing these up in simple documents, or even just writing them up as the back of the napkin kind of diagrams. And that's where this next stage comes in. Sometimes we see people start actually at this diagram stage. So drawing some kind of diagram is really powerful, because that gives people another documented element of how this works. What's really interesting are these kinds of diagrams can actually be drawn with using a very, very standardized set of tools. The tool I use is a thing called websequencediagrams.com. It's actually an online tool that lets you type in text and produce diagrams. So you literally type in text that looks like this. This is a web sequence diagram formatted file. So this says I want to go from home to weather data, and I want to do it by invoking city name with an argument, or by city ID with an argument, or by lat and longitude. And that actually generates this image. And you can modify the kinds of image styles and so on and so forth that you use. But now you have a documented format. So that documented format generates an image for you and makes sure that everybody can see the same image. This becomes part of the check-in material and source control. This becomes part of the pipeline for build processing. The image itself can become part of the documentation of the API. Now, there are lots of ways to do this. I use VS Code a lot. There's actually a plugin for VS Code that automatically reads these sequence diagram files and renders them inside VS Code, so you don't have to use an external website. Another website that uses the same format is called Plant UML. I have many customers that use Plant UML. And that also has a plugin for Visual Studio and VS Code. So if you're already using Plant UML, you can do that. Here's a rendering of a little bit more complicated element inside VS Code. So while developers are working, they can literally just highlight a document and it renders the image for you. And you get a sense of looking at each one. And then you can even edit the image. This is where the iteration comes in. You edit the image, and then it generates, you edit the file, generates a new image. You get to share it with the community again. Finally, I do a lot of things on the command line. So I built a tool that actually just generates the image using the API for the website, because they have an API. That solves my problem. So I can just have this WSD gen tool. It reads the WSD file and generates a PNG file. Or I can generate a PDF. Or there's a handful of other things that you can do. So this whole process of doing this diagram is sort of the first step in the chain of standardizing the way we talk about your API. So now we have this workflow tool, and we have a handful of ways of doing this in a GUI interface, online itself, inside our editor, or actually doing it in a command line mode. So once we've created this workspace, we've got this workflow and we've got a diagram, it's really important to do this thing called applying vocabularies. This is where we standardize the interface so that it looks like other interfaces that people work with. In the user interface mode, this is where we apply CSS, where we make sure that all our user interfaces look similar to humans so that they'll understand where buttons and knobs are. So we're consistent in the way we present information. So the API, or the machine equivalent of that, is making sure we use vocabularies. And vocabularies are all the property names that we have: latitude, longitude, ID, city, name, address, all those terms. And they're all the actions. Query by city, save record, remove record, all these phrases, all these action elements, that's the vocabulary. So you can think of the data elements as inputs on a screen. You can think of the action elements as buttons or links. And we would want to standardize those human interfaces to make sure that it was easy for people to navigate and hard for them to click on the wrong thing or hard for them to fill the wrong value into a field. And that's what applying vocabularies does. And essentially what we want to do is normalize the words we use on the interface so that it matches the words everyone else in the organization or everyone else in the community or the ecosystem is using. And there are lots of ways to do this. There are lots of open vocabularies. A group called schema.org has a fantastic open vocabulary. This was started by Microsoft, Yahoo, Google, and eventually Yandex from Russia. So they're all search engine people, and they wanted people to mark up all of their search results using the same words, all of their documents and content using shared words so that their search results would be improved. So this is a way of creating a style sheet or a standardized vocabulary for search terms. So that's one of them. Often, as I mentioned before, there's an industry vocabulary. It's called a FHIR, F-I-H-R, for health, that was started in the US. GDPR has its own vocabulary. PSD2 for banking in Europe has its own vocabulary. There's another banking standard called BIAN, B-I-A-N, which is more of an object model approach. These are all standardized industry elements. In your own industry, You probably have one or more vocabularies that you can rely on. And by applying the vocabulary to your interface, not necessarily to your internal object model or your data model, just to your interface, then that means when you output a message, people who understand that same vocabulary, all the people in PSD2 or GDPR, understand what you're printing out, what you're doing. Finally, for internal use, often you have your own schemas or object models or data models that are called the canonical model or something like that. Those can be broken down into individual property names. What you don't want to do is you don't want to make an object hierarchy your vocabulary. That's not a proper way to do it. The object hierarchy is much more about the implementation detail. What you want to do is take all the terms, all the properties, and all the actions, and all those other elements. That becomes your vocabulary. And there are a handful of ways that you can do this. So here's an example. There's some more detail about this weather data API, lots of things, words that they used in their original API for direction and status and all these other things. But it turns out that's a very localized set of names. There's actually a thing called web sensor data, which talks about the data weather sensors have and has a standardized naming for them. We'll get to that in just a second. Here are some other examples of standardized naming on the web. Link relations, I mentioned schema.org, but now it's also related to activity streams, microformats, Dublin Core for librarian and information management. Then we talked about semantic sensor web was the one that's for weather, and you might have your own internal vocabulary as well. So here now is a renaming of the exact same interface using standard semantic sensor data. So it's coordination.long, coordination.lat, weather.id. It has its own naming convention. Now, this doesn't mean that I'll change my internal models for objects or storage, but it means when I produce my interface, when I produce my messages on the outside, I'll always make sure that they use the same style sheet, the same property names and data names that everyone else is using in the industry. So that's normalizing properties and specifying actions. You see actions down here in the bottom. Often those actions are very specific to your own organization. Often industry standards only focus on data names, but more frequently now, like banking, PSD2 actually focuses on actions, get account balance and things like that. So you'd be using their names as well. But especially internally, you'll often have your own names. It's really important to share these definitions. It's not so important to share the action definitions. These last a lot more over time. You change actions, add new features, add new functions all the time. But you use the same data model for a very long time. Most organizations use the same general data vocabulary for decades. So standardizing that's really important. So once you have that, once you've got this notion of you understand the workflow, you understand, you can diagram it in a standardized way, and you've normalized the terms you use so that lots of people can understand them, we need to get that set of results into a document that's reusable. And that's really called a profile or a description document. And it's important to think of these in different ways. So describing the interface doesn't actually define it. When I describe a person to you, she's got brown hair and is wearing jeans and tennies or something like that, I'm giving very generalized, vague information. If you looked in a room, you wouldn't be able to know exactly, maybe. I'd have to get more and more specific. And the more and more specific I get, the more and more narrow my definition until it only works for one case. So there are lots of description languages that are designed to talk about things in a general way. This is what a shopping cart vocabulary and workflow looks like. This is what a credit card authorization workflow looks like. So the languages that are pretty popular right now are ALPS, application level programming, semantics, DCAP from Dublin Core's application profiles, and JSON Home from the IETF. These are the three that we see most often. There's another one that just came out this year, but it's very, very new. Like it was just in January. That has something to do with profiles for hypermeter type language or something like that. I don't quite remember the details, but these are starting to be more common. Now, these are the general descriptions. The more specific definitions can also be very important because they begin the first level of implementation. So often what has to happen is we need to turn these descriptions into implementations. So you might recognize some of these names. So web service definition language, right? Swagger or OpenIO, RAML or resource application markup language, or APIary's Blueprint language. These are now actual specific definitions of APIs. They say exactly what the URL is, they say exactly what the protocol is, they say exactly what the format is, and one of these Swagger definitions, it works for only one website in the whole planet. Because not every website is going to have the same URL or support the same languages or all those other things. So definitions are implementation specific, descriptions are generalized. In things like DCAP and ALPS, you say there's an action to save your shopping cart. It doesn't say if it's a post, it doesn't say what the URL is, it does say what the arguments are and what you can expect in return, but the implementation details are left later. The power of a description language is that you can use the same description language for a client-server implementation, a CRUD implementation, a SOAP implementation, a reactive implementation. The same description works every time, but that's not true for Swagger. Swagger cannot give you the proper information for a SOAP API or for a reactive API. It can only give you one for a CRUD-style API, right? And it can't even give you one for a hypermedia-style API. It only works for sort of a gRPC-style or a CRUD-style API. So that's why we keep this information in this generalized form so that lots of people can use it later. It gets really popular. We can start to use the ALPS information to create a GraphQL interface. And that's a specific definition of that design. So it's kind of hard to see, but this is what the XML version of ALPS looks like. You can see that it just lists all the descriptors and has simple descriptions of them, or text descriptions, and then all the actions, and they have arguments that go with them. They say, when you take this action, it's a safe action, like it's a query. You pass one argument and you get this weather data back. This is actually all the possible data you could get back. So it shows each one of these examples. If this was a longer document, it would list things like unsafe actions like writing or reading or deleting information as well. Now what's nice is this also, most of these languages are supported in both JSON and XML style. And that's true for ALPS and DCAP. I think home might actually be just JSON only. So the good news is there's a utility. I actually wrote a utility that turns our web sequence diagram into a valid ALPS document. So we can generate an XML or a JSON ALPS document. And you can write other controllers as well. So they generate, this is like the JSON version that's generated from the weather information that we talked about earlier. So again, the idea is now I've got a tool chain process and I have this standardized description document. Now this description, this profile document can also be used in real time. So it's negotiable. I want to get weather information. Can you please use version 1 profile of the weather information? So now both server and client understand which vocabulary they're using when they're talking about weather data. And I could actually talk in multiple vocabularies. We have some customers that do that. At the same time, you can generate some other elements as well. You can actually use this generalized description to generate a reference API documentation. It's very simple, but it's enough to help developers understand things in various ways. So reference documentation is kind of its own creature, right? They're handy, but they're insufficient. Reference documentation just touches on one small part of what a good set of documentation for APIs involves. What are the concepts behind this? This is the API for managing weather data. This was built by our company because we do X, Y, and Z. How do I get started? What is my 2-minute drill? What is my in 5 minutes I'm up and running experience? What are the common tasks people need to do with this API? If I'm trying to solve a problem and not just touch it for the first time, where's the thing that allows me to update the weather conditions for Porto? How do I do that? Look it up in the set of tasks. How do I solve a problem? I keep getting this error condition. I keep getting rejected when I make this query. How do I go and solve those problems? That's another kind of documentation. And then finally, that detailed reference of every endpoint and every argument and every property and every action and so on and so forth. So that's a full set of documentation that is part of implementation detail. That doesn't happen in the design process. But by generating a reference documentation, by getting something up and running from the early design documents, you start to get something that looks familiar to developers, and they can start using that as a guide. I didn't include it in our talk here because it'd take a little bit more time, but there are also generators for these other things like Swagger and APIary Blueprint and things like that from things like the sequence diagrams or the ALPS diagrams. So you can bootstrap some of this other work as well. So there's another utility that you can download. These are, I'll show where these are at the end of the talk, but it's another one that converts, that generates some simplistic documentation. So sketching that workflow, generating the diagram, generating that generalized description document, and generating some reference documentation for people to work with. These are all tools that help you prepare for building the API. Now, one of the things that I get people say a lot is, that's a lot of work. Actually, that's where most of the work ends up, in my experience. By the time you get to building your API, actually coding it, that should be dull. Right? We know where most of the terrible things are. We know which parts are going to be hard. It's literally like building an apartment building. We go out to some place, we dig a hole, we pour a lot of cement, we bring lots of people together at the right time, and it all gets built. And it's not a lot of super discovery. It's not a lot of, oh my gosh, I guess we hadn't thought about, we should put doors on the building kind of stuff. That's handled in this phase. There's actually some other things in another talk I do about sketching, prototyping, and building, how you can actually get an iterative process for actually doing production, so you don't have to build it all on the first day. But these design artifacts get checked into source control to become part of the history of the project, and even the changes over time are kept. All right, so I've kind of talked about a handful of things, but there are several key elements. Thinking about your API as a product, not just a consumable product, but an industrial product, a product of work, a product of a process. That means that you start this idea about thinking about design early in the process, matching people's needs, coming up with a business viable strategy, keeping an eye on customer value, and solving a problem. And then this idea of having a method or a process that you go through. Most organizations, they have something like we've just talked about, and they have all of their projects on a big dashboard in the hallway, so everybody can see how many projects are in the diagramming phase, how many projects are in the vocabulary phase, how many projects are in the profile phase, how many projects have generated reference API documentation and been approved to be handed over to development. So you can also monitor this. So as your organization gets larger, you get lots of feedback, lots of information, and that gives you a chance to give individuals more autonomy. I don't care so much about how you go about doing these as long as you hit these milestones and generate these documents. You don't have to use these utilities. You can use your own. As long as we get the diagram, as long as we get the normalized vocabulary, as long as we get the profile, we're ready to go. So you can start giving people a lot of freedom. And that's part of that virtuous cycle. The more freedom they get, the more creative they can be and still meet the goals. And they can do them in any way they wish, whether it means doing them faster, more accurately, more detailed. And then they start to teach other people in the organization how to do that as well. So having a process is something that you can teach, something that others can learn, and something you can even modify and improve over time. So I talked about a lot of things. I'll have these slides for you, but you can find the slides on this site, and then I'll also turn them over to the group. You'll find the utilities on GitHub. If you're interested in more of this or other things that I'm working on, you can hit my newsletter. And if you're interested in some of the books I've worked on, you can hit that up as well. I want to say thank you very, very much. We've got a few minutes. I'd be happy to answer any questions that you might have, even if it's on topics we haven't had a chance to talk about. Otherwise, I want to say again, thanks, and I hope I get to see you again. Thank you very much. Thanks. Any questions at all? Yes? Yes, yes. Yes. Who? So the question is, who should design the API? The right person. So in some organizations, that design is actually kept in a design team. I'm working with a large bank right now, and their only job is to go through the design process. And they're just like a product design team. They're an internal team that knows about design, and they go to these different places. Other organizations, it's the centralized architecture team that does the design process. They have the design model, and they're the ones that go through and help teams solve a particular problem. In lots of international organizations or global organizations, a central location isn't efficient. They have some kind of architecture committee or API committee in each of their locations that does it. Even to the point I have one company that's relatively small, and centralizing it doesn't make sense at all. They taught all their teams this kind of process, and they have 7 or 8 teams, and the teams just do their own design, and then they have a sort of a design committee, like everybody from one of the teams participates in a design committee once a month. So it really kind of works in different ways. So this cuts a lot into culture and how organizations already work. And there's this sort of slider between centralization and distribution, right? As you centralize, you have more control, but the rest of the group has less opportunity, right? They can't affect the system. You're only going to be as good as your central group. As you distribute it to more people, you have less control, so you need a better process or a better dashboard to make sure that all the things you've distributed don't get off into some weird places and do some odd things. So it turns out it's that it depends kind of nonsense, but it really has to do with what fits in culture as to where you can do it. And often we see companies over time move this design experience around. Yeah. Does that help? I don't know if it really does. Anything else? Yes? It's very good. And at which time do you start writing tests? As soon as you move from this to code. Like, so often, we talk in the next unit of the stuff that we talk about sketch, prototype, and build sets. So you're creating a sort of a mock server in the very first day. We talk about release on the first day, which is usually just a stub. And that stub, in test environments, that stub has a test, right? And so you start from the very first day. That also is different in different cultures. When you have a really automated test-driven environment, it's really easy to start writing the tests right away. In organizations that rely heavily on human testing, manual testing, they tend to put that off, and they do that after they have enough material. They turn it over to a team that starts writing tests mostly for humans. And that's a very different strategy, but the sooner the better is the best strategy. So the very first time you come out of this, and you're going to have some mock, something that works at a URL, that's usually time to start having tests. So that's a really good question. That's good. Anything else? Okay, well, I'll be around for the rest of the day today. And again, thank you very much, and I hope I get to hear from you. Thank you. Thanks.